Hello, Mr. Ryan. How are you today? Okay. So we talked about the minimum spanning tree yesterday, and then the algorithm we teach is what? What's the name of the algorithm we talk about? Kuska. Okay. Kuska. Yeah. Okay. Kuska. So Kuska minimum spanning tree. Okay. So let's review a little bit. Okay. Let's review a little bit. So we have this the graph.
No cycles.
No cycle weighted and direction.
And the
minimum
okay, minimum spanning tree.
That looks like a diamond or something.
Yeah. So
1, 2, 5, 4.
So
no, wait.
So what are we doing? So we have four vertices, and then how many edges we need to build for this minimum spanning trees?
So 1, 2, 5.
So how many edges?
1, 2, 4.
So for n vertex.
1, 2, 4.
2, 1, 4.
Okay.
2, 1, 4. 2, 1, 4. 2, 1. It's 2, 1, 4. It's 2, 1, 4.
Okay.
It's 2, 1, 4.
So let us. So first of all, we have all the vertex, which has n vertex.
It doesn't matter what.
It's 2, 1, 4.
What doesn't matter about the order you say it in?
What do you mean order?
Like.
So it's 2, 1, 4. So can you say 1, 2, 4?
It's okay. But first of all.
I say 2.
First of all, look, we have n vertex, 4 vertex. So we need to build a minimum spanning tree with the 4 trees. Yeah, each one with a separate, no edges, just vertex. And then we start picking the edges that does not form the cycle. So the first one we know to pick is 1, and then the second one we pick 2, and then now look 3. 3 because it has formed a cycle. So that's why we don't pick it or we skip it. So the next one is 4, right? Yeah, easy peasy. So this is the minimum spanning tree. Okay, so that's a question. With n vertex, what's the
n-1.
Okay, n-1, yes. n-1 edges, okay? Okay. So this one is that we start by adding the edges, right? Look, we have this vertex and we start by adding the edges. Yeah, adding the edges. So the time complexity, as we talked about, we need to sort these edges by in ascending order of the weight, right? So this is E, O, E log E, right? Remember? Sorting the edges.
You can just say what's the time complexity.
Yeah, the time complexity, okay?
You can just say what's the time complexity instead of just telling us.
Oh, you want me to ask you the questions? Okay. Okay, so because we are using what kind of data structure we using?
Quicker.
No. What kind of data structure you use to...
Disjoint sets.
Disjoint sets. Yeah, okay, we're done. Okay? Yeah. This question is especially for you, yeah, because you answered it correct last time, right?
Meow.
That's okay. Now OE, so okay, that's a very, very tricky question. For the n vertex, right? If there's a graph with n vertex, n vertex, and how many edges are there?
n-1.
No, I mean the maximum. Like for example, like if there are 4, look.
There's a cycle though.
Yeah, I mean the graph, okay, I the graph. If there's a graph, okay? If there's a graph
N.
with n vertex, yeah, n vertex. And how many maximum number of edges can you think about? Think about it. Look, it could be crossed. How many of these? Look.
Lots.
Yeah, I know.
Infinity.
How is that infinity? Look, for each one you have the edges to n-1, right? So for each one you have the edges to n-1.
N times 2.
No, look at 4. This is how is that n times 2? Look, this is 3 edges. How many? How many are 3? Right? Yeah.
That's n.
So 3 edges. That's what? 2 plus 1, right? So it's n-1 plus n-2 plus here 1, right? So for example, there are n edges, n vertex. The first vertex has connections to the n-1, right? So it's n-1. So for the second one, it has the edges to n-2, right? So it plus 1, right? Okay. So that's the total number of edges. Okay. So it's in the scale of n square, right? It's in the scale. It's not exactly the same as. Do you get it? So.
I got.
Well, why this is not working? Okay.
Because you missed the part which is stuck to the board with
Wow.
the camouflage.
So okay, so maybe okay. So what I'm trying to say here is
This, you forgot this dumb thing.
yeah. That's okay.
There we go.
Okay. That's
You need to put numbers though.
no. I don't. For example, this one. Let's consider the first vertex, right? This first vertex. So you can have the edges to how many vertex are there?
5.
Yeah, but if this is the n, there are n vertex
And
and then
minus 1.
n minus 1. Okay, so n minus 1.
Hey!
No, this is not.
Aw.
No. Okay, next one because I'm trying to.
Man.
You can okay. When I said the questions, then you answer it. Okay. Okay. So now, so for the second one, how many edges you can have? 2. N minus 1, but we already count this, so we don't count it again. So
Yeah,
that
I
will be
literally said anyone.
n minus what?
N minus 1.
N minus
N
1.
minus 2.
Yeah, and then the next one.
N minus 3.
Yeah, why is the n minus 3? Because it has to.
Hey,
And minus 2. And
how
minus 2.
No, look you because already have 2, so you can't count these, right? So it's n minus 3, yeah. N minus 1 minus 2. Okay, so in this case.
I said N minus 3.
Okay, and then after
Why?
1.
And minus
Right?
4.
Yeah, up to 1, right? So what's this? What's this sum?
N square.
I don't know yet. Look, so the first item is the sum will be n minus 1 plus 1. How many items are there? Times n minus 1 divided by 2, right? Yeah. So this is the equation to sum the arithmetic sequence, right? So 1 plus 2 plus 3 plus 2n minus 1. The first item, the last item, how many items are then divided by 2? So it's n times n minus 1 divided by 2. Right? So this is the number, this is the possible number of edges for a graph with n vertices, okay? So because we know this OE log E, right? Yeah? And if this E edges is the V square, right? Because look, this is the V square. So if we say OE log V square, okay? Yeah? So look, this one, we have say log A to the power of B. Actually, you can put a B. Look, this is magic. You can put a B to the before. So it becomes B times log A. Okay? So this is the logarithm transformation. For example, like log 2 to the base of A, right? A is 2 to the power of 3, right? 2 to the power of 3 is
So,
A, right? So that equals what?
3 times log 2.
We're down 3 times log 2. It's the same, yeah? Make sense?
Yeah,
Yeah.
that's a question, right?
Yeah.
So.
No. Okay.
Yeah.
So the time complexity, we can also say, look, we move it to before, right? So then we drop the constant. So OE log V is also okay, right? Okay, so now let's come into the today's topic with more questions, okay?
No, is it?
Yeah, come on. Today we're going to talk about another algorithm to compute the minimum spanning tree, which is called the Prim. Okay?
Aha.
I don't know. Okay, so the previously,
No, it's not.
we picked
It's
the
half away.
we pick the edges and we add it to the forest, right? And now this time we want to what? We want to pick the vertex instead. So for example, like okay, so let's see what we can get. Okay, C, D, and let maybe here. Okay, let's say 1, 2, 3, 4, 5. So
1, 2, 3,
before
4.
we pick the smallest edge, but now this time it's different. We can pick first of all which vertex you want to pick. It
The
doesn't matter.
highest.
It doesn't matter. Pick one. A, B, C, D, or E.
A.
Okay, because why is it doesn't matter? Because eventually all these vertices will be in the minimum spanning tree, right? Right? It's connected, right? So we just pick A. Okay, so from A, how many edges? Is
2.
to 1 and 2. Okay, so now we pick.
Hey!
Now this is easy. It's on board. Now we have 1.
It's not on the board.
Okay, so then we pick the smallest one, which is A to B. This is 1. Okay. Now we have this, yeah, we have this tree. Now A or B, how many edges connect to A? Now I have this one, yeah, I have two, this one. And how many edges connect to B? How many edges?
3.
So
3. So one of them already picked.
do you have a green now? Okay. So look, I have one A, B, right? So there are two out of it. So first of all, I pick this one, right? Pick A, and then there are two edges, 1 and 2, because I pick the smallest one, so which is 1. Okay. So now I already have these, yeah? So how many edges connected to this? This one, right?
Yeah.
This one, and this one, and this one, yeah? Right?
Mm-hmm.
So I pick the smallest, which is 2. Right? 2, 3, 4. I pick this, the smallest one. So I pick this, which is D. 2, right? Yeah? Then the tree I have built for now is this. I include this, right? So now how many edges connected to these A, B, or D?
What?
3.
So no, I already know the tree, minimum spanning tree has A, B, C. And how many edges, which we haven't
6.
added, connects to the vertex here?
1.
Why, which one?
C.
C, and then there will be how many edges?
4. No, 2.
I did.
4 and 5. Okay, so
he
how
said
many will
how
pick?
many?
Okay, how many?
1.
One. How many vertex? 1. How many edges? 2. So we pick 4 or 5?
4.
4. So we pick a 4. 4. Let's see. Do you get it? Do you understand this process? So first of all, we randomly pick. Okay, so the step 1, we pick a vertex. It doesn't have to be. It could be random. Pick a vertex. Pick a vertex. V-E-R-T-E-X. Pick a vertex. And then we need to separate this to this pick a vertex. We want to put it in this tree, right? Pick a vertex and put it in the tree. And then we have S equals all the vertex. All the vertex. And then we need to find a vertex. Okay? We need to find a vertex in S. Right? Connecting to the existing tree with the minimum edges. Right? So what are we trying? What are we doing here? Look. So if we have AB, right? Then the edges connected to A or B is this AD, BD, or BC. And then we just need to pick the smallest of them, and then try to include these new vertex, new edges in the tree. Make sense? Okay, let me write the steps. Okay. Let me write the steps. Okay, so now the first one we want to build is the T will be equals to the empty set, right? Empty set. This is the tree we are going to build. Define prims. We have a graph, right? So first of all, we have a T equals empties, right? And then no, what? So we want to build a vertex. Which is vertex? Let's say the vertex will be E. V will be, let's say we start from the beginning, the first node, okay, 0, okay, 0 node, or any node, alright. Come on, what you doing? Why the V is not
That's
equal.
in different place.
Okay.
That means that.
Okay.
But it's in different
Why V is not equal? How many? Look. Okay. No, we don't need this.
Then
Why
one's in
V?
different place.
What do you mean different place? No. This is the same. I'm just writing. Why
Yeah,
V
but
is
it's
not
not
equals
equal.
to. Yeah. Why V is
curved.
not equals
So
to
it's not.
G dot V, right? Because we're going to include all the vertex anyway. The minimum spanning tree is contains all the vertex, right? All the vertex of the graph, original graph, and it's connected, right? Because we're talking about a connective. It's just the edges is the n-1 edges, right? Right? Come on, sit there. Why V not equals the G dot V? Why we haven't built enough vertex? We haven't included enough vertex in in the minimum spanning tree. Now we need to find the edges. We need to find the edge mn, right? The mn need m and n is the vertex number. Need to find the edges. Find edges. Find edges. Okay, so let's say we want to find what? We want to find the edge. This function will return the m. It belongs to existing v, right? Existing v, and then n belongs to g dot v minus m minus v, right? This is the vertex we have included in the minimum spanning tree, and this is the vertex that we haven't included. And we want to find out mn in these. M belongs to v and n belongs to g dot v minus v. And also this edge is the smallest, okay? And this is the smallest. And then after that, then we can do what? We can include the graph. T equals T including the graph, right? Graph is m to n. And then V will be equals V including the vertex. Vertex is n, right? This is the vertex we want to include it, right? And that will be it. So the time complexity for this one, okay, this is a bit tricky, okay, is O E times the log E log V plus V times log V, okay?
That's
No, because we're going to use the heap. Remember the heap? What's a heap, by the way? Anyone? This
first in priority out.
No. First in priority out. Yeah, kind of, but not quite. The heap, remember, is the binary tree with the
It's
top
a data structure.
data structure. Okay,
It
so
was the third data structure.
priority queue, yeah, the one that you said is priority queue. So every time when you take an element out, it's always with the priority, right?
The smallest.
Smallest. Yeah, with the smallest. Okay, so that takes all, because we have v vertex, so that requires log v. Okay, and we need to traverse all the edges. But because the vertex number is smaller equal to the edge number, right? Am I right? Don't write it on the floor. Come on. Okay, so the time complexity can also be O E log v, because this one is trivial, right? It's E plus v log v, so it's trivial.
There, guys.
Okay. So the space complexity is OV, you know, because we need the data structure to store, right? We need to store these. Yeah, we need to store the number of the vertex. And okay, so I'm going to write a tree, a graph, okay, and then you tell me, okay, you tell me how we going to build the minimum spanning tree using this, using this Prim's algorithm. But first of all, let me give you one question. What's the difference between Prim's and Kruskal?
They start from different places.
You? What's the difference between Kruskal and Prim's? What are we doing in the Kruskal? We start adding the what?
We start adding the minimum.
Okay, so one, two, 3, 4, 5, 6, 7. Okay, so for the Kruskal, we are picking the smallest edges and add it to the forest, right? We adding the edges. But for the Prince, we adding the vertex, right? Yeah? Make sense?
Yeah.
So okay, so for now, you want to try with the Prince algorithm. How are we building this? That was 2 Pokemon cards. You can work together, then each one shares one.
Okay.
Yeah. Remember what did I tell you about? Randomly pick one Okay, so pick A. Oh, slowly, yeah, A. And then, okay, so from
And
this.
then we move to the smallest. 1.
Okay, 1, B. Okay,
3,
here. Okay, whoa.
1.
Okay, so now what happened? What's next? You start from, you
And
count
then-
how many edges connected to these.
And this.
Okay, yeah. Okay, yeah, that's okay. Yes?
See?
Okay, and then how many edges connected to these?
And then.
Yeah? So can you tell me how did you do it? Come on. I just need to explanation.
Because we just
looked at for the smallest.
how
No,
much
no, no,
how
it's
much what does it connect to, and we
Count it, yeah?
and
Okay.
and
Okay,
we
so
did
look,
small.
you pick A, then how many edges
We
connected
need
to
to
A?
do more
2,
this.
1 and 3, you pick 1, right?
Yes.
And now you have A, B. How many edges connected to A and B?
1.
How many edges?
2.
This one, right?
Yeah.
And I pick the smallest, which is 2, right? How many edges connected to 1, A, B, C? 7, 4, 6, yeah? Then I pick 4, right? Alright?
Yeah.
And
It's a
how many
Chinese
edges?
word.
How many edges I pick connects to A, B, C, D? A, B, C, D. So look, so how do you do that? So how many edges connected to A, B, C, D? You just do this. How many edges? It'll be easier.
1.
Huh? How many edges connected to A, B, C, D? Come on. How many edges left?
1
Which one is that?
and 2.
2. Yeah, come on. 5 and 6 you pick up. Do you get it?
Yes.
You sure?
Yes.
I feel like not quite. No. Okay.
Do.
So for example, okay, I give you 1, 2. Okay. You want you want the extra bonus one? Okay, bonus one. Okay. I'm going to write another one, and you tell me.
How much do you get?
Same. That's lot.
Then 2.
Can we work together though?
You decide.
We'll work together.
You decide.
Yeah, we'll work.
Okay. But you need to tell me exactly, not just write it. You need to tell me. Okay? Do you understand? You need to tell me.
Still in the same way.
Yeah, same way. Because because you might think about, it's different, right? 1, 2, 3, 2, 3, 3, 4, 5, and then 5, 1, 1. Okay. Come on, that's it.
Okay.
So first of all,
So we start with A.
Start with-
Always.
Yeah, we like to.
okay,
then
and
we
then how many
got-
edges?
Give me that green one.
Yeah. No, yeah. You can't go that fast. You need to tell me how did you make the decision.
Because you got D because it has 2 connections. Since 2 is this.
More
Yeah.
than
I
that.
know. Yeah.
There are
and-
3 or 2 and 2 is the smallest.
No. Actually, you can just mark it here. Okay, so it'll be easier. Okay, that's why you choose. Okay, now you have all. How many vertex you got?
And
How many vertex you got?
You got
1.
2.
A and D. Okay, and then what's next?
We choose.
We choose this.
How many? What? How many?
Because you have 1, 2, 3.
Oh, I haven't put it here.
4.
So okay, so what?
You have
And then we
1,
go up to
1,
B.
2.
And then
3, 4. Yeah. Okay, and then we
we
pick
go
a
up to the smallest.
smallest. Yeah.
one.
So, okay, we're done.
And we're definitely not going up, so our only choice is down. The reason why we're not going up because we don't want cycling.
Okay, so what's next? What's next? How many edges connect to A, B, B?
It's 3.
This.
And
And
this.
then G
Yeah.
is
And then you choose the smallest one.
1.
Okay, maybe
Here.
I put a 4 here. Okay, right there. Okay,
It's
2.
here.
Okay. And then
I'm thinking of way different.
and then how many edges connects to these?
And I'm just using
Yeah.
this.
Yeah. And how?
And then this is the.
Definitely the smallest. Yeah.
Okay.
Okay, and then
And then this is the
Yeah.
one of the smallest.
Yeah, and how many edges connected? Because look, you have A, B, D, C, E there, and then you can just pick one of them. It's okay because they're all 5. No.
And this 5.
Because this one is already included, right?
So you
Yeah.
circle it.
You get it? Yeah.
Yeah.
Okay, so to sum up, you have these 3, right? Because look, what have you done so far? Is pick a A, and then you pick a D, you pick a B, you pick a G, you pick a E. I don't know. Yeah. You start building the vertex, right? You start building the vertex by choosing the smallest edge. Okay. Okay, that's it for today. Good job.
Bye.
Bye.
Bye.